Untuk nomor 1, the coordinates of point A are 6, minus 7, and the coordinates of point B are minus 6, 2. Point M is the midpoint of AB. L1 is the line through A and B. The line L2 is perpendicular to L1 and passes through M. Write down in the form of y equals to mx plus c the equation of L2. So the first thing that we need to do here is to set a goals and step-by-step process. So this is the information that we have. So if I write down here, so the information that we have point A and we have point B. Okay, so let's say I'm going to like point A, let's say it's in here. Right, so if I have, okay, I'm gonna draw a sketch of Cartesian plane, maybe like this, right? So let's say point A is 6, minus 7 is about here, right? This is point A, and then point B is about minus 6, 2 is about here. Okay, so we have point A and point B, and then it said that point M is the midpoint of AB. So if I draw a straight line in here from A to B like this, the midpoint is the midpoint is what do you call it, the point M, right? It's point M. So we don't know yet. I mean, like it can be here, it can be here, it can be anywhere. But in order to know what the coordinates of the M, right, we only need to find the midpoint from the formula of a x1. So the midpoint is just like adding the x and then divided by 2, and then adding y and then divided by 2, right? So it's like x1 plus x2 divided by 2, and then the y1 plus y2 is divided by 2. So because we know that the point A is 6, minus 7, and point B is minus 6, 2, we can just go straight to the M, because like we just add these two numbers and then divided by 2. So 6 plus minus 6 is equals to 0. 0 divided by 2 is just 0. And then minus 7 plus 2 is minus 5. And then minus 5 divided by 2 is minus 5 over 2. So this is the coordinates of M. So in this image, I'm going to use other color maybe. Okay. Okay, here this is the value of M. I mean like the coordinates of M. So I'm going to use green, yellow is that. So 0, minus 2 is it's about here. Yeah, this is point M. Okay, so why is it there? Because we know that the x coordinates is 0, so because it intersect with the y axis, so this is the value. This is the point of M. Okay, next L1 is the line through AB. So this green line that I made, this one, right? This is the L1. Okay, line number 1, right? And then the line L2 is perpendicular to L1 and passes through M. Okay, so L2 passes M. So it can be like, it can be here, it can be here, it can be anywhere, as long as that line is, that line is going to be passing through this point M. But it said that it is specifically that L2 is perpendicular to L1. So what does perpendicular means? Perpendicular lines means that two lines in which they make exactly 90-degree angle. So if I use, say I'm going to use red, so the line will be approximately here, like this, and that is going to make a 90-degree angle, right? So it can be 90-degree, 90-degree, and 90-degree, right? So I only need to write the last one. So here we go. This is going to be L2, right? This L2, because it's perpendicular to L1. Okay, and then you want to know the line equation of L2. So in the form of this, right? You want to know, again, the equation of L2. So whenever you want to find a line equation, normally we need at least like 2 points or 1 gradient and 8 points. So for this L2, what we know from this line is that this L2 passes through point M, right? So I'm going to write down the information here. So L2 passes M, and we know that the coordinates of M is 0, minus 5 over 2. This point here, right? Remember that when we want to construct a line equation, we need to get at least 2 points or 1 point with a gradient, right? So we don't know other points that passes through L2, right? But we can find the value of M, like the gradient of this line. And since we know that if two lines are perpendicular, let's say I have for line 1, I have a gradient. So let's say for L1, I have a gradient of M1. So M2, we can find the gradient. Okay, so let's find the M1 first. Okay, so because we know that gradients just rise over run, right? And the rise is the change of not the change yeah, the change of y, and then the run is the change of x. So I can use these 2 points because they L1 passes through point A and point B. So I'm gonna write the coordinates maybe here. We have this is 6 comma minus 7, and this is minus 6 comma 2. Okay, so the rise means that you're focusing on the y value and the AB. So this one and this one, right? So you subtract them. So remember that the difference between midpoint you add them, but for a gradient you subtract them. Okay, don't be swapped. Okay, so the rise in here is these 2 numbers, and then you subtract these 2 numbers. Okay, so this number here and this number here. Okay, so I'm gonna start with the top with B. So I'm gonna subtract 2 by minus 7. So it's 2 minus 7, and then over. Right, M1, and then the run is going to be the x, right? So this one subtracted by this one. Okay, that's going to be minus 6 minus 6. Okay, so M1 is going to be 2 minus 7 is going to be 9, and minus 6 over minus 6 is going to be minus 12. We can simplify that as minus 3 over 4. Okay, so we get the gradient of L1, right? Okay, now let's go back to L2. So because we know that L2 is perpendicular to L1, and okay, since we know that L2 is perpendicular again, L2 is perpendicular, right? Perpendicular to L1. So which means that M2 is going to be like this one here. Remember that if I have like M1 is A over B, and if we have another line, let's say M2, another line which has a gradient of M2, then M2 will be equals to minus B over A. So you only like to swap the B and A, right? And then if one is positive and the other one will be negative, it's always like that. Okay, so if I have this as M1 is minus 3 over 4, so M2, because it is perpendicular to that, so I will get 4 over 3, right? So this is negative and this is positive. And you only need like to swap the number, the 3 over 4 becomes 4 over 3. Okay, so now we have all the materials to construct the line equation, right? So in conclusion, we only need to do one more step, right? So we have all of the ingredients in here, which is this one and this one, because we know that L2 passes, I'm going to write down L2 passes point M, which is the coordinate is 0, comma minus 5 over 2. Like and then has a gradient of 4 over 3. Now, since I have these 2 information, I can just use the formula to construct the line equation. So I'm going to put this down here. Okay, so which means that the line equation of L2 will be y minus y1 equals to m times x minus x1. Okay, so only to substitute because we are using m2, so write an m2 here. So I'm going to write that down as y minus 5 over 2. Okay, so this is going to be x1 and y1. Okay, so I'm going to use other color this time, maybe. This one might be right. So this is x1 and this is y1. Okay, so minus 5 over 2, and then equals to x minus m. I forgot the m. The m is 4 over 3, right? 4 over 3 bracket x minus 0, because we know that x1 is equals to 0. Okay, so now we only need to simplify this. We have minus minus, so it becomes plus 5 over 2, and 4 over 3 times x is 4 over 3x, and 4 over 3 times 0 is just 0. So because it said that it wants to have the form of this y equals to something, which means that we only need to move this here, right? Because there it is an addition, so you will put that onto the right side, you will get minus 5 over 6. So this is the final answer. Okay, for number 2, the equation of the line L1 is 2x plus y equals 10. Okay, so the question is for A, write down the gradient of L1 and the y-intercept of L1. Okay, so remember that if I write down, if we have a gradient y-intercept form of line equation, which is y equals to mx plus c. So whenever you see an equation like this, okay, or you can rearrange equation, a linear equation like this, then you will get the gradient and also the y-intercept. So let's have an example. If I have like y equals like 3x plus 5, so which means that this line has a gradient of 3 from here, right, the coefficient of x, and the y-intercept is going to be 5. As simple as that. Okay, so we're using this concept, we can say that if we have like equation of L1 is this one, if you want to find the gradient and the y-intercept, you only need to convert this into this form. Okay, so that is going to be y equals to something, right? So if I have like 2x plus y equals 10, I can just like move this here, right? So, or I like subtract both sides by 2x. So, or I just like move that here because y equals to, I'm going to move this here. So I'm going to put the one that has an x variable in the first term of the right side of the equal sign. So it's going to be minus 2x plus 10. Okay, so this form is the same thing with this one, right? So which means that we can just like go straight and take the numbers. So for the gradient, right, so the gradient of m1, right, because this is line 1, so it's going to be equals to minus 2. You just take it from here because we have already made it into this form. Okay, so the same thing with the y-intercept, because we also have this form, and this is going to be the value of c, and that value of c, which is, we call it the constant, it is going to be the y-intercept. So the y-intercept is going to be equals to 10. Question B, the line L2 is parallel to L1 and passes through the point of P, which is 0, 3. And the question is, write down the equation of L2. So previously, so for number 2a, we have found the equation of L1 in the gradient y-intercept form, which is this one, right? And then we want to find the equation of L2. So what we need to see here, what is actually the relationship between L2 and L1. And here it said that L2 is parallel to L1. As we know, if two or more lines are parallel, then which means that the gradient are going to be the same. So remember that gradient is actually a slope. So if I have like a slope like this, right? So if I have another line which is parallel, they're going to have the same exact slope, right? Like slope value. So slope is the same thing as gradient. So which means that if I have the gradient, we know that the gradient of L1 is minus 2 from here, right? So which means that because they're parallel, so which means that M1 is going to be M2. So because we know that M1 is minus 2, so M2 is also going to be minus 2. So that is going to be the gradient. Okay, so as the previous question from number 1, we know that if we want to construct a line equation, because it is being asked here, the right hand line equation, right, about 2, we need like 2 points, or we need 1 point and a gradient. In this question, it said that this L2 passes through this point here. So this line passes through P, which is 0, 3. And actually, we have these two objects, like two materials that you can use to construct a line equation, right? Or we can use the formula of y minus y1 equals to m times x minus x1. So again, because we can use this formula if we know the gradient and 1 point, any point, yeah, on the line. So I'm going to write down and mark the x1 and y1. So this is going to be x1 and this is going to be y1. So what we don't need to do is just like substitute all of the numbers. So we have y minus y1 is 3, and then the m is minus 2, and then x minus 0. Okay, so this 3 comes from here, the 0 comes from here. Okay, so now let's expand. We have y minus 3 equals to minus 2 times x is minus 2x, and minus 2 times minus 0 is just 0. Okay, so because it doesn't specifically needs you to like have a certain form of a line equation, so normally we write down in a gradient y-intercept form. So I'm gonna remove that minus 3. I'm gonna move that to the right, and that will be minus 2x plus 3. So this is going to be the answer for I. Okay, next, it said that find the x coordinates. Here, find the x coordinates of the point where L2 crosses the x-axis. So you need to understand what does this mean. What is this condition? So if I have like a Cartesian plane, we have like y-axis and x-axis, and then it said that the line equation. So this is this line equation here, the L2, right? So it's going to be passes through 3 because we know that the y-intercept is 3. And the green is minus 3, so it's going to be down, right? Okay, here we go. So I'm going to use actually other color to make it clear. Okay, so it passes through 3 in here, right? And it's going to be like this because we know that if going to the left from left to the right is going downhill, it means that the gradient is going to be negative. Okay, so it said that you want to know the x coordinates when it crosses the x-axis. So where do you pass the x-axis? It is in here. Okay, so any point on the x-axis, the value of y will be equals to 0, right? So let's say I have here a point in here. Let's say this is 6. So this coordinates of this point is going to be 6, 0. So let's say I have another example. Let's say I have another point in here. Let's say this is minus 4. So the point in here will be minus 4, 0. So anytime you have a point on the x-axis, the y value is always going to be 0. Okay. So again, for this condition, because we want to find the x coordinates or the x value when it crosses the x-axis. So in here, the y value will be equals to 0. Okay, so we have this information, and then if you want to find out the value of x, you only need to substitute that y into this equation because this is the equation of L2. So let's substitute that. We have y is equal to 0 because y equals to 0. So substitute the y becomes 0, and then equals to minus 2x plus 3. Okay, now I'm going to move this one here, so it will becomes addition. So 0 plus 2x is just 2x, so 2x equals to 3. And then I'm going to remove this by dividing both sides by 2, or just like move that 2 to the right side, you will get division. So x is equals to 3 over 2. Okay, for number 3, we have an image on the left side. And then we have point A and point B are sites, with B having the coordinates of 4, 6. So again, guys, put into habit. If you have some information, just write down the information first. Anything that you can write, just write it down. We have says B is the coordinate of B is 4, 6. So I'm gonna write down in here 4, 6. And L is an edge. Okay, this line here is an edge. So it's like the perpendicular line of AB in which it passes through the midpoint of AB. Okay, so and then the equation of this perpendicular bisector of the line segment from A to B is y equals to minus 2x plus 9. So this equation here belongs to L. So L is this one here. It's the perpendicular bisector. Okay, so right here. So the L is going to be y equals to minus 2x plus 9. Okay, the question is find the coordinates of point A. Okay, so how can we do that? Well, actually, guys, we know that point A and B, the connection between point A and B is that if we draw a line like this, right? They have a gradient, and then this line L will passes through the midpoint of these lines, right? This line AB, right? So let's say this is M. So in order to go here to know what that is, so we need to construct again what we are trying to find here, and then try to make a step-by-step process. Okay, so we start from here. Okay, what can we know from this line? So line L, right? Line L, let's say L1, right? L1. That is y equals to minus 2x plus 9. Okay, so what can we retrieve from this equation and connect that to line AB, right? So as we know that line AB and line 1, L1, is perpendicular, right? Because it is a what do you call it, a bisector, right? Is perpendicular bisector. So which means that line L1 and line AB is going to be perpendicular. So let's remember that we can find one gradient of a line if we know if we know other lines that is perpendicular to that line. Okay, so let's write down the information here. So what information we can retrieve in here is that this line, this L1, I have a gradient of M1 is equals to minus 2, right? We just take it from here because this is the form of a gradient and Y-intercept. Okay, so what is the connection between AB? So AB is actually also because sorry, so line AB, I'm gonna write down line 2, maybe line 2 here. Line AB, which is EISAB, has a gradient, right, of M2. So M2, because we know that the perpendicular bisector, or the L1, is perpendicular to this line, right? Perpendicular. So if one is, remember, if I have like M1 is equal to A over B, if it is perpendicular to the other line, which has a gradient of M2, let's say, then M2 is going to be minus of B over A. It's just like swap the A and B, and then if one is positive and the other will be negative. Okay, so keep in mind that. So which means that we can just swap the numerator and denominator. Okay, so if you're confused, guys, how can I swap, because I don't have anything like on the bottom here, right? On the denominator, actually you have one. So this minus 2, I can write it down as minus 2 over 1. Right? So if I want to like swap the numerator and the denominator, I just like swap this 1 and 2. So I will get 1 over 2. So since we know that M1 is minus 2, M1 is negative, so which means that the M1 will be, M2 is going to be positive. This is negative and this is going to be positive. Remember that if they are perpendicular, one is positive and the other one is going to be negative. Okay, now we are going here. So we know the gradient, right? So the gradient is 1 over 2. So the question is, how can I connect this B into A, right? So B into A, so actually it can, we can find the value of M first. I mean like the coordinates of M. So how can we do that? Because we know that line AB, line 2 in here, this one, line 2, this one, is perpendicular to this line, and then it has an intersection in here, right? Intersection of that midpoint. So I can write it down like this. Okay, so I can find that value of M by doing a linear like system of linear equation, right? And then try to like maybe substitute or eliminate anything you want. Okay, so this time I'm going to use substitution. So I'm going to write down both of the equation from L1 and L2. Okay, so L1 has an equation of y equals to minus 2x plus 9. And then L2, I have an equation of y. Do I have L2? Oh, not yet. Okay. Oh, okay. We need to construct that first. So we need to construct the y L2 by what? Because we know that L2 is what do you call it? L2 is the line from line AB. It has a gradient of M2, which is 1 over 2, and it passes through 4,6, right? Remember from the previous question, we can construct that flow, right? So we have the information for L2 is that it passes 4,6, right? Point B, this one, right? So if I drag a line here, right, it's going to pass this point B. And then I also know that we have a gradient of 1 over 2. So from these two information, we can construct line 2 equation. We get y minus y1 equals to m times x minus x1. So okay, I'm gonna mark that as x1 and y1, right? And then you only need to substitute all of the numbers. We have like y minus 6 is from here, right? and then equals to m is 1 over 2 from here because we are searching for the line 2, so this should be m2. So x minus 4, because the 4 comes from here. Okay, so I don't need to expand the bracket. I have y minus x equals to 1 over 2 x minus 2. Okay, so which means that I can rearrange that into a gradient y-intercept form. I will get y equals to 1 over 2 x minus 2 plus 6, right? So this one goes here, becomes plus 6. So if I add that minus 2 and 6, I will get y equals to 1 over 2x plus 4. Okay, so this is the line equation of L2. So what can we do with this one and this one in the connection to the M? Okay, so because we know that the M here is the intersection, it means that at this point, right, at this point is going to be the same with, I mean, like this point is going to be, this one point is the only point that passes through both of L1 and L2. So again, we can use a system of linear equation if you want, like substituting or eliminating. You can do that. I'm going to use a substitution. So let's say this is y1 and this is y2. So because they are going to be the same for the value of y and x, so I can write down as a conclusion so that y1 is going to be y2. So why is it like this? Because again, guys, we are looking for the coordinates of point in here, in which the coordinates of x and y will be the same for both of the line, for this line and also for this line. So they are going to be the same. So we can write down y1 equals to y2 or x1 equals to x2, right? But for this case, I'm going to write down y1 equals to y2 because it's going to be easier, because we know that y1 is this one and y2 is this one, right? So I only need to substitute that. So I will get y1 is equals to minus 2x plus 9, and y2 is 1 over 2x plus 4. Okay, from here and from here. Okay, so we only need to solve this for the value of x. So I'm going to move that to x to the right side and 4 on the left side. So it's 9 minus 4 equals to 1 over 2x plus 2x. 9 minus 4 is 5. And then that's going to be 5 over 2x. So x is going to be 5 divided by 5 over 2. And that will be equals to 2. Okay, so after I have the value of x, because we know that we need a coordinate in which it should has a x value and also y value. So in order to find out the value of y, you can choose one of the equation. It's up to you. You can use this one or you can use this one. Why? Because for both of the line, we have that certain point in which the value of x and the y is the same. So let's say I'm going to use the y2. Okay, I'm going to use this one here again. Again, guys, it doesn't matter which one do you choose from one of them, from two of the equation. You will get the same number. Okay, so the y will be equals to 1 over 2 because we know that the x is 2, so substitute that with 2. Okay, first 4, and then half times there's just 1, so y is equals to 5. Okay, so in conclusion, we have the coordinates of m as 2, 5. Okay, so if you go back to the image here, this point here is 2, 5. Okay, so actually we have like a like calculation method for finding the value of a, but we have I have a shortcut for you guys. Okay, so this is how we do it, because we know that the distance from M to B and M to A is the same because it is the midpoint. So we can just like start like this. Okay, can we see a pattern? So if I go here to here, right, you subtract that by 2. So which means that if I go here, so the x will be 0. Why is it 0? Because 4 minus 2 is 2. 2 minus 2 is going to be equal to 0, right? Because this is like subtracting by 2. So I subtracted again by 2. So the x value for the point A is going to be 0. Okay, so that is for the x value. And you do the same thing with the y value here. So the y value is such from 6, and then you go to 5. Oh, you go down 1 point. So you go down 1 point again. 5 minus 1 is going to be 4. So A is going to be 0, 4, and this is going to be the final answer. Number 4, points A, B, C, D, and E are given in here. I'm gonna use this one, A, B, C, and E. We have these points, and then it also has been what do you call it, mark in the Cartesian plane, which is this one, right? A, B, C, D, and E. And then represents snow shelter in the Blackburn National Forest. So they are snow shelters. These snow shelters are illustrated in the following coordinates axis. Horizontal scale 1 unit represent 1 kilometer. Vertical scale 1 unit represent for 1 kilometer. So it's proportional, yeah, for the x and y. Okay, so question here is calculate the gradient of the line segment AE. So what you need to do is just like drag a line, a straight line from A to E, right? Like that. Okay, and then it's only asks about the gradients. Just remember, guys, that the gradient is just rise over 1, right? So rise over 1. And because it said it wants you to calculate only AE, so you only need these 2 points, the A and the E, okay? So that is going to be, remember that the rise is the change of Y, so on for the numerator, you're focusing on the value of Y. So this guy and this guy. So it's going to be 3 minus 1. And the run is going to be 7 minus 3. Okay, 7 minus 3. 3 minus 1 is 2. 7 minus 3 is 4. So it's going to be 1 over 2. So that is the gradient of AE. Okay, next question. Okay. The park ranger draws 3 straight lines from an incomplete Voronoi diagram. Find the equation of the line which could complete the Voronoi cell containing site E. Okay, so remember that if you want to construct a Voronoi diagram, we need to connect all of the points together, like a point A with point B, point A with point C, well, and point A with point D, and so on, so on, so on. Okay, so 2 points, and then you make a perpendicular bisector between those 2 points, right? And then you start to like, oh, this is the pattern, and so on, so on, so on. Okay, so in here, what we need to focus on, because it's only said that find the equation of the line which could complete the Voronoi diagram containing site E. So let's see if E has connected through all of the other points in here. So E and C is connected with this line, right? Because this is the perpendicular bisector of line AC. And then we have like E with D, we have this line, right, as the perpendicular bisector. So we have done that. So, and then we have E and B, well, we have this one here. And the last one is A to E, and we don't have that yet, right? So AE should be, if I write down, if I draw a straight line for AE, so it should be approximately like this, right? For the perpendicular bisector, but we don't have that, right? So which means that we're going to construct that. Okay, so I'm gonna draw it in here. So this is point A, and this is point E. Okay. And then I would like to complete the Voronoi diagram and find out the line equation of the perpendicular bisector. So our goal is to find out, if we draw a line in here, a straight line, in which it passes through the midpoint of AE, what is this line equation? Okay, so that is the goal. Okay, so let's do it step by step. Okay, first of all, if we want to construct a Voronoi diagram again, so you connect one point to the other and then to make a perpendicular bisector. So if you want to make a perpendicular bisector, you need to do this thing first, okay? So, and then construct and then find the line equation. So the first thing that you do is to connect A and E, right? So these 2 points. This 2 point is A and E, so I'm going to draw a straight line here. So that is A and E. And then the second one is to find the midpoint of that line A. So I'm going to put it here, approximately. It's M, right? This point here, exactly in the middle. And then we try to find out what is the coordinates of M. Okay. So let's say, because we know that the point A is, what do you call it again? Let's go up again. It's 3, 1, 7, 3, 7, 3. So this is 3, 1, and this is 7, 3. Right? So if I want to find the midpoint, we can go back to number 1, right? Just add and then you divide by 2. So the midpoint here, I'm going to write M. So I'm going to rewrite the point A and B, A and E. So A is 3, 1, and then E is 7, 3. So again, like we do previously, For the m is just like adding these two numbers and then divided by 2, and then adding these two numbers and then you divide it by 2. Okay, so 3 plus 7 is 10, 10 divided by 2 is 5, 1 plus 3 is 4, 4 divided by 2 is 2. So this is the midpoint of AE, right? So this point is 5, 2. Okay, so remember guys, when I said before that if you want to construct a line equation, we need to have at least 2 points that passes through that line, or we have a gradient and a 1 point, like any point that passes through the line. Okay, so we have this point M as a point in which the line will passes, right? So if I draw the dash line like we have it in here, right? So if I have a dash in here like this line here is going to be perpendicular with line AE. So remember guys, we can find this M, right? So let's say this is M of 2, right? M2, and this is M1. So if I have this line AE as line 1, let's say this is L1, so I can find the gradient of L1, right? So for L1, the gradient, so M1, is going to be again rise over run, and we know that the rise comes with the x-axis. Oh, what actually, actually we have done that before in here, right, guys? It's 1 over 2. So let's not do that because we have done that. So you can write down 1 over 2. Okay, so we have all the materials that we need, right? Because we know that it passes through this point and it has a gradient of this one. So which means that we can find the equation of that line. So let's say it's line 2. Okay, so because we are using M2. It's going to be equals to, okay, so I forgot. So I'll find the M2 first because we know that M1 and M2 are perpendicular. So if M1 is 1 over 2, then M2 is going to be minus 2 over 1. So again, you swap the 1 and 2, like the denominator and numerator, and then if one is positive and the other will be negative, so it's going to be minus 2 over 1 is just minus 2. Yeah. Okay, so again, we can use the formula y minus y1 equals to m times x minus x1. This formula is going to be used to construct a straight line equation with a gradient and 1 point that passes through the line. So we have this point, sorry, this gradient, sorry, not that one, this gradient here, gradient of this like the perpendicular bisector, and this point here is the point that passes through is this line. So I can write this down as x1 and y1. So the line equation will be y equals to y minus 2 is equals to minus 2 times x minus 5. Okay, so I get this 2 from here, I get this 5 from here, and I get minus 2 from here. Okay, again, just substitute all of the numbers, and then we can expand the bracket. We have y minus 2 equals to minus 2x plus 10. Since it wants us to write the form like this, so which means that we are going to move all of the terms to the left side, right? So I'm going to move this one and this one, all of them to the left side, which means that it leaves nothing or 0 on the right side. So we get y minus 2, and then minus 2x becomes plus 2x, plus 10 becomes minus 10. That is going to be equals to 0. So I can combine these two because they are like terms. Minus 2 minus 10 is 12. So I can write down 2x plus y minus 12 equals to 0. Number 5, rainfall in a city was measured at 3 different locations, A, B, and C. The results are shown below. Okay, so this is the table of the rainfall in a certain place, like point A, point B, and C is given in the image here, right? And then it has the image is constructed has construct a Voronoi diagram. Okay, so the question is, use the nearest neighbor interpolation to estimate the rainfall at these points. Okay, so let's do it one by one. I'm gonna zoom it a little bit, guys. Okay, so now let's start from point A. Point A is, so not point A, question A is 3, 0. So let's mark 3, 0 on the Cartesian plane. It's about here, right? Okay, so let's see. In which of these A, B, and C is closest to this point that I have? it is point C, right? Because again, because it is on this region, right? Because this region belongs to C, so which means that it is going to be closest to C, right? So because of that, we are going to use the sample from location C. So for this one, because it's closest to C, then the rainfall is 17 millimeter because C is 17 millimeter. Okay, the next one is point minus 2 comma minus 2. I'm going to use this color here. Okay, minus 2 comma minus 2. Okay, so again, mark the point on the Cartesian plane as minus 2 comma minus 2 is about here, right? So for this one, because it lies on one of the perpendicular bisector, so you can just like find the average of those 2 points, okay, or those 2 sides, because we know that this line here, right, is the perpendicular bisector of point A and point B, right? So line AC, sorry, AC, yeah, A and C, right? So which means that I can connect this with C, and I also can connect that with A. So we're not going to use just C or just A, but we're going to use both of them again, because the point that we have in here has the same exact distance to A and also to C. Okay, so which means that it's closest to A and C. So the rainfall will be the average of A and C, which means like 13 plus 17 divided by 2. So 13 and 17, because we have 2 sides, then divide that by 2. So you get 30 divided by 2 is equals to 15 millimeter. Okay, next one is 0.1 comma 1. So 1 comma 1 is about here. Okay, so for this point, it is exactly on the vertex. Like for this point, it's going to be it has the same exact distance to B, to A, and also to C, right? So using the concept that we have to answer B, because for question B, the points are close to A and C, so we use A and C. Because for this one, for this point here, 1 comma 1 here, it's closest to all of them, so we can use all of them, right? So it close to all, right? It has the same exact distance, so which means that the rainfall will be equals to 13 plus 8 plus 17 divided by 3, because we have 3 points, yeah, 3 sides. Okay, 13 plus 17 is going to be 38 over 3 millimeter, or I can write down this as 12.6 millimeter, okay, 12.7, like 7. Okay, number 6. This Voronoi diagram shows the location of 5 towns in a rural area. A rubbish dump is to be established somewhere in the region so that it is as far as possible from the nearest town. Question A. Where should the rubbish dump be established? So in here we have a lot of like sites in here, right? Like A, B, C, D, and E, right? So we have 5 sites, and we have it has constructed. In the image, we have the construction of the Voronoi diagram, and we have like these 3 vertex, right? So this one here, and this one here. Okay, so it's like, yeah, the vertex. And then it's about where should the rubbish dump be established, because we know that it's we need to find a vertex from these 3 vertex, right? This was one, this one, and this one, in which it has the average is more average distance to all of the sides A, B, C, and D and E. So let's say we pick this point over here, this V. Let's name this. Okay, let's name this one with V1. This one is V2, and this one is V3. So it names as a vertex, right? So let's say if I pick V1, right? If I pick V1, it is going to be okay. It's going to be very far from D, right? But it's going to be very close to A, right? So that's why V1 we cannot choose the V1, because that is going to be too near to point A. Okay, now what if we pick V3? Again, V3, okay, to point A or side A is going to be quite far, but it is going to be close, right? It's going to be close to D or to C or to E, right? So it's not going to be like an average. It's not more average a distance to all of the sides in here. So if we choose V2, V2 is in the middle. I'm gonna erase that one. I'm gonna use red this time. Okay, this one over here. All right. So this point here, the vertex, this vertex, is going to be like from this to here, from this to here, and this to here, this to here, and this to here. Although maybe it's like, oh, this one is like closest to B, closest to E, and closest also to C, because this vertex is going to be has the same distance to point B, point E, and point C. But if it goes to point A and it goes to point D, it's not going to be too far or too near, right? So in this case, we're going to choose that vertex as the rubbish stem. So this one over here, yeah. So question A should be 0.20, 10. Okay. Question B. How far is the dump from the nearest town? So we can what they call it, because we know that what they call it the okay, because we know that we're using this one, right? So which means that we're going to find the distance from that 20 to 20, 10 to one of the points in like the nearest or the furthest. Okay, okay, so how far is it down from the nearest town? So in here, because we know that we're picking this one, so this point here is going to have the same distance to E, to B, and to C. It's not going to have the same distance with we don't know yet, but it's not going to have like the same distance with D and A, because like that vertex, right, the vertex that we choose, the vertex that we choose, which is in that point 20, 10, is like separating the region of E, B, and the C, right? So that's why if we draw a like a circle, if we draw a circle, it's going to be a circle, and then all of them going to have like this. So sorry, it's not a circle actually. I mean like my image is not a circle, but we can use that concept. So again, because it means that we can choose one of the points of C, E, or B to calculate the distance. Okay, so I'm going to use B this time. Okay, so in order to find out the distance, right? So this is the distance from one point to another point. So I'm going to write down the formula here. So the distance is going to be the square root of x2 minus x1 squared, and then plus y2 minus y1 squared. So where does this formula comes from? This is actually from Pythagoras formula. Okay, from the Pythagoras formula. Or if you wanna if you don't want to use this formula, it's actually I can like put the point here 20, 10, and then here let's say it's 48, 26, right? The point B and point vertex 2 here. So we can like construct a right angle triangle actually, right? So it's gonna be like this and like this, and going to be like this, and this is going to be a right angle. Okay, so we can like find this length here, right? Because this line is the x like it's a horizontal line, so it represents the x value. So it's 20 to 48. So 48 minus 20 is 28, right? And then we have this from here to here is from 26 to 10 is going to be 16, right? So that's why we're using this formula. This formula actually comes from the Pythagoras formula. So we can use the calculation here. So it will be the square root. So the distance is going to be the square root of 28 squared plus 16 squared, and that will be the square root of 1040, or equals to 32.2. It can be kilometer, it can be like miles, because it doesn't have any unit in here, so it's just 32.2. Yeah. Okay, so you can, if you want to use this formula, actually it's the same thing, right? So if I have that x1 minus x2, right? So actually it's from here, right? X1 minus x2 minus x1 is that this one minus this one, you get 28, and this one minus this one, you get 10. Okay, so we have that for question B. And then let's go to question C. Which town are closest to the dump? Okay, so in here, okay, point C. Is that which towns are closest to them, because again we know that this point is going to be the dump. The point in here is going to have the same distance to a point B and to point E and also to point C. They are going to have the same exact distance, so which means that the town that closest to them is town B, C, and E. Okay, so last question. A proposed location for the dump is 25,15. Show by direct calculation that the location you found A is preferable. Okay, so that's fine. So it's 25,15. Okay, let's see from the image here. If I go back to the image, what is actually that 25,5? Okay, so if we see 25,5, it's approximately going to be about 25.5 is like here, right? 25,15, is it? Yeah, 25, yeah, somewhere in here, right? So this one here is going to be very close to B, right? I mean, like compared to A, E, or C, or D, this point is going to be closest to B. Okay, now because it's said that we need to calculate whether this dump that is proposed it's not suitable, it's suitable or not, we need to find the what do you call it, we need to find the distance, of course. Okay, so the distance from that dump to the closest what do you call it, the closest town, which is B, right? So you do the same thing like using D. I'm gonna use the x1 minus x2 minus x1 this time. X2 minus x1 squared plus y2 minus y1 squared. Okay, so that is going to be, this B is going to be like x1 and y1, and this is going to be x2 and y2. So that is going to be just again use your calculator. You have, okay, so if you calculate that again using the calculator, you will get the square root of 650, and it will be 25.5 units. Okay, so again we don't need we don't have a unit here because it doesn't say anything about it. It can be like meter, kilometer, or miles. It can be any unit, right? Okay, so why we cannot use this? Because we know that it the purpose of making this a rubbish dump is so that this rubbish dump, this point, this vertex, the place is going to have like more distance, right, to houses and so on and so on. So if we see that, oh, this the distance of this point that is being proposed is like closer from the previous one. The previous one only said 32.2, like it's more far than this one. So this is not going to be I mean, like we cannot accept this one because it's closer to one town, which is B, right? So we can conclude that hence, right, 20,10 is more preferable than 25,15 since it has larger distance. Larger distance, is it? Yeah, larger distance to the closest town. Okay.